Hello, and welcome to the section on Kubernetes deployment. In the previous section, we looked at Kubernetes architecture and some of the key concepts. In this section, we will look at the various aspects of Kubernetes deployment, such as writing the YAML file, methods of deployment, and deployment using Helm. We start the section with this video on writing YAML files for deployment. YAML files allows us to write specifications for objects such as deployments, replica set, services, namespaces, service accounts, etc. We then use the YAML file with the kubectl client to send the deployment information to Kubernetes. The deployment information is considered to be the desired end state of deployment, and Kubernetes tries to bring the cluster to that end state. To demonstrate how to write the deployment YAML, we will deploy a simple Spring Boot API microservice. The source code of the app can be found on github.com/Shah Spring Boot API. I have created a Docker image for that app and we will use that for deployment. The image is at Mithil Shah Spring RESTful API on Docker Hub. The application has a single endpoint at /hello. It takes in a particular name and returns hello name. Deployment can be used to create replica set and pods. In our case, we will create a deployment that contains a replica set and a pod containing a Spring RESTful API container. To understand the structure of any object, we can use the kubectl explain command. Before we write the YAML, let's look at how our deployment will be structured using the explain command. We start with the deployment object from version app/v1. We will write the metadata and then the spec, which is the deployment specification. Within the specification, we are interested in selector, which allows us to select the pod that is managed by the deployment, replicas that allows us to specify the number of instances of the pod, and a template that will be used to create the pod. The template consists of metadata and the specification for pod. Within the pod specification, we describe the containers that will be part of that pod. Let's begin writing the YAML file. The API version for deployment is app/v1. Kind is deployment. The metadata contains name. Next, we write the deployment specification. The first thing in deployment specification is the selector, which tells Kubernetes how to select the pods that are managed by this deployment. We specify the number of replicas as 1. This number can be increased later on. To tell Kubernetes how to create the pod, we write a template. The metadata of the template should contain the same labels that the deployment uses for selecting the pods. These are the same labels that we wrote earlier. The main part of the template is the pod specification, where we specify the container. In our case, we have a single container that uses the Spring RESTful API image from Docker Hub. The image pull policy can take various values. In our case, we tell the Kubernetes Docker container to download the image if it's not present. Within the pod subsection, we specify the port that will be exposed on the container. The API is not exposed outside the pod. To access it from outside the pod, we need to define a service. We will talk about services later on, but for now, the only other thing that we need to know is that to access it outside the pod as well as outside cluster, we need to define a service of type node port. Let's begin writing the service. The API version of the service is v1. The kind is service. The metadata lists the name and labels. The service specification has a type which we write as node port. Next, we will define the various ports of the service. The node port is the port that is exposed outside the cluster. To use the RESTful API, we will use this port. The port specifies the port exposed by the pod. The target port specifies the port that the service targets. That is, a Spring RESTful API is run on port 8080 by Tomcat. The last thing that we need to specify is a selector that is used to pick up the pod that the service targets. Let's select the labels that we put on the Spring RESTful API pod. This is all we need to run a Spring Boot RESTful API on Kubernetes. Let's see if we can access the service. We use the minikube service command to access the service URL and the curl command to hit the service. We pass in the name Mithil and get back hello Mithil. In a production environment, we'll have the service behind a load balancer and optionally an ingress controller. In a later tutorial, we will see a production grade cluster with all the bells and whistles. But for now, enjoy your first dynamic application deployed on Kubernetes. In the next video, we will look at the various ways to deploy applications to Kubernetes. See you in the next video.